Hi everyone, welcome to lesson 3.2, position, velocity, and acceleration. In this lesson we're going to be solving rectilinear motion problems involving position, speed, velocity, and acceleration. So remember that the derivative can determine the slope, but it can also be used to determine a rate of change of one variable with respect to another. We saw that in the last lesson on related rates. But in this lesson, we want to focus on a particular function, s of t. This is a notation that is used throughout AP Calculus, and you will see on the AP Calculus exam. The s of t is a position function. It is a function of a particle's position with respect to the origin as a function of time. So let's think about the simplest type of motion. This would be motion along a single dimension or a single line, either horizontally or vertically. So what are some things that we might imagine would fall into these categories? So horizontal movement would be things like people. We see cars, rivers. So these are all things that might have horizontal linear motion. So things that might have a vertical motion or vertical component of motion would consist of things like balls being thrown up or dropped, rockets, anything subject to gravity or some other force that is acting along the y-axis. All right, so the function s of t, or x of t if it's along the x-axis, that gives the position relative to the origin of an object is a function of time. So as the object moves in its position, changes over time. Therefore, the velocity function v of t is the change in the position function over time. So, in other words, velocity is the first derivative of position. So v of t is equal to s prime of t or x prime of t, depending upon what your position function is and how it's denoted. Now, since we have talked a lot about the derivative as being a measure of slope, it's also important to think about it again from the perspective of average rate of change. And so what this allows us to do is to determine the average rate of change for a particle over an interval. And so if you think about this as it applies to motion, we're talking about a time interval. And so we may be given some endpoints for values of time in seconds or minutes, and we're asked to then determine what the average velocity is for a particle on that interval. Another important thing to remember is that the average rate of change, which is essentially the slope formula, is the slope for a secant line. Remember, it is the instantaneous rate of change that is the slope of the tangent line. So in this case, our rate is going to be distance over time, and our average velocity is the change in distance, or delta s, divided by the change in time, delta t. And if we were to think about this in terms of a difference quotient, we would have f of t plus delta t minus f of t over delta t. And if we were going to calculate this as a derivative, we limit as delta t approaches 0. So again, just to contrast the average rate of change and the instantaneous rate of change, an average rate of change is the slope of the secant line, and that's calculated by taking endpoints of an interval and using those in our slope formula. The slope of the tangent line is found by taking the limit as delta t approaches 0. In other words, letting this endpoint get smaller and smaller and smaller in terms of its distance away from the other endpoint, letting that distance between the endpoints, that delta t, approach 0. And when you take that limit of the difference quotient, the slope of the tangent line, or the secant line rather, becomes the slope of the tangent line. So the instantaneous velocity tells how fast something is going at the exact instant and also in which direction it is going. It is a signed value. Remember that speed is the absolute value of velocity. All right, so let's use a table to lay out the relationships for motion along a horizontal line and vertical line given the three possibilities for values of velocity: greater than 0, positive, less than 0, negative, and equal to 0. So if I am on a horizontal line and velocity is positive, that means that we are moving to the right. Velocity is positive. If velocity is negative, I am moving left. And if the velocity is equal to 0, we are stopped. Now, if I am moving along a vertical line, particle moves up. The velocity is negative, the particle moves down. And again, if it's equal to 0, the particle is stopped. So once again, velocity is a signed value. Velocity gives the position and magnitude of the rate of change for the position function. Speed is the numerical value. Without the sign, it is the absolute value of the velocity. Now, just like velocity is the rate of change of the position function, in other words, the first derivative of the position function, acceleration is the rate of change of the velocity function. That means that acceleration can be found by taking the first derivative of velocity. So in other words, a of t is equal to v prime of t. And likewise, you can think of this as the second derivative, s double prime of t, of the original position function, s of t. And so remember that just because an acceleration is 0 does not mean that the object is stopped. It just simply means that the velocity is not increasing or decreasing. In other words, you're traveling at a constant velocity. So you can think about the cruise control on your car as being an example of constant velocity. You're certainly moving, you're just not accelerating or decelerating. So let's make a table now that gives us information about the acceleration along horizontal and vertical lines of motion. So if the acceleration is positive, that means that an object is being pushed to the right. If the acceleration is negative, then it is pushed to the left. If the acceleration is equal to 0, that means that we have a constant velocity. So the speed is unchanged. The velocity is unchanged. For the vertical line, particle is just simply pushed upward. And if the acceleration is less than 0 or negative, it is pushed downward. And again, an acceleration of 0 means that the velocity is not changing. So constant or unchanging. Now, this is a very helpful chart to memorize. So techniques for speeding up and slowing down. If velocity and acceleration have the same sign, that always means that the object is speeding up. I have a positive velocity and I am accelerating. I have a positive acceleration. If I have a negative velocity with a negative acceleration, that means that I'm still going to be speeding up. So in other words, the speed increases when the signs match.